Okay, so in this video, we're going to explore the new types of factorising on the Leave Insert Higher Level course. The only new types of factorising are to factorise the difference of two cubes and to factorise the sum of two cubes. You need to learn these statements. That x cubed minus y cubed is equal to x minus y times x squared plus xy plus y squared. And then the sum of two cubes is the exact same, except that we swap. The first sign here is a plus, the second sign is a minus. Whereas here the first sign is a minus, then the second one is a plus. The way that I always remember it is if I'm getting x cubed minus y cubed, then the first sign is going to be a minus. Whereas if I'm getting x cubed plus y cubed, the first sign is going to be a plus. So you essentially need to learn those, and that's what we're going to go through in this video. So let's first go through an example of how you would factorise the difference of two cubes. Okay, so if we needed to use this formula for factorising the difference of two cubes, the question might look something like this. You might be asked to factorise 8x cubed minus 125. I know that this is the difference of two cubes because the cubic root of 8 is 2 and the cubic root of 125 is 5. So I could rewrite 8x cubed as 2x all to be cubed. And I could rewrite 125 as 5 all to be cubed. I'm using the difference of two cubes rather than the sum of two cubes because there's a minus between the two terms. I've now rewritten my expression in the exact same form as this. Here this is x cubed minus y cubed. Here I have 2x to be cubed minus 5 to be cubed. So basically just instead of an x I have a 2x, instead of a y I have a 5. I'm just going to rewrite the right hand side of this equation, except instead of an x I'll put in 2x, instead of y I'm going to put in a 5. So let's just sub in and see what it looks like. Instead of x minus y I'm going to have 2x minus 5. Instead of x squared I'm going to have 2x all to be squared. Instead of x times y I'm going to have a 2x and I'm going to have a 5. And instead of y squared it's going to be 5 to be squared. So I want you to recognize that this is exactly the same as this. I've simply substituted 5 instead of y and 2x instead of x. Now let's simplify this. The first bracket I'm going to leave it exactly as it is. It's just 2x minus 5. The second bracket I have 2x times 2x, which is 4x squared, 2x times 5, which is 10x, and 5 times 5, which is 25. Now, that is your answer. Those are the factors. Often when I give this to students, they feel they're inclined to multiply this out now. If you multiply this out, you're going to end up back where you started. Remember the factors, this is all I want. I want one bracket multiplied by another. So the factors of 8x cubed minus 125 are simply 2x minus 5 times 4x squared plus 10x plus 25. Let's have a look now at the sum of two cubes. It's essentially the exact same thing, it's just we swap the first two signs of our formula around. Now let's imagine we were asked to factorise 64b cubed plus 1. The cubic root of 64 is 4. So 64b cubed can be rewritten as 4b all to be cubed. And the cubic root of 1 is just 1. So 1 can be rewritten as 1 cubed. And this time there's a plus in between them, which means I have to use the formula for the sum of two cubes, which is exactly the same as the one we used in the previous example, except that we've swapped the first two signs. Last time the first sign was a minus and the second one was a plus. This time it's a plus and then a minus. So I'm just going to sub in, except instead of x I can sub in 4b, instead of y I can sub in a 1. So let's see what that would look like. X plus y in this case would be 4b plus 1. And x squared would become 4b all to be squared. While minus xy would become minus, and then x, which is 4b, and my y is 1. And then I have y squared at the end, which is just going to be a 1 to be squared. Now in order to get the full marks, I need to just simplify the second bracket a little bit. The first bracket I'll leave it exactly as it is, just 4b plus 1. 4b times 4b gives me 16b squared. Minus 4b by 1 just gives me minus 4b, while 1 squared just gives me 1. And that's your final answer for the factors of 64b cubed plus 1. Always be on the lookout just to see if you should factorise any further, but there's no need for us to factorise any further here, so that's my answer for example 2. Now that you've seen me do an example of the difference of two cubes and the sum of two cubes, I'm going to give you a few questions and I want you to factorise them yourself. Okay, so in order to practice that material, I want you to factorize these 5 expressions. The first 3 are basic enough, they're standard enough factorizing. The fourth one is a little bit trickier because the second term is b plus c to be cubed. And then the fifth one is the way I think it is most likely to come up. You need to think outside the box for this one. That one will be the sum of 2 cubes, but I want you to figure out how can you manipulate it to use the sum of 2 cubes. So pause the video now, work through those 5 questions and compare it to my solutions. Okay, the first one was very simple. We have a cubed minus b cubed. Clearly this is just in the right form. It's in the form x cubed minus y cubed. You need to learn off that x cubed minus y cubed is x minus y times x squared plus xy plus y squared. Which tells me that if I'm given something like a cubed minus b cubed, you essentially just rewrite this, except instead of an x you put in an a, instead of a y you put in a b. So your factors in this case are that, and that's all you need to get the marks for part 1. The second one again was standard enough. We had 343x cubed minus 27a cubed. The cubic root of 343 is 7, so the first term can be rewritten as 7x cubed, while the second term can be rewritten as 3a cubed. So now I'm just going to sub into the formula that we've learned off for x cubed minus y cubed, except instead of an x we put in a 7x, and instead of a y we put in a 3a. When you simplify out your bracket at the end, your second bracket should end up as 49x squared plus 21xa plus 9a squared. And that's your final answer for part 2 here. The third question was the sum of 2 cubes because there's a plus between them. The cubic root of 1000x cubed is 10x, and the cubic root of y cubed is y. So I can simply sub into the formula for the sum of 2 cubes, and when I simplified out the second bracket, I got 100x squared minus 10xy plus y squared. So these two brackets, or these two factors, are my final answer for part 3. Okay, so part 4 was far messier. We have a cubed minus b plus c to be cubed. Once again, we have the difference of 2 cubes because it's one term cubed minus another term cubed. In this case, instead of x, I'd have an a. Instead of y, I'll have b plus c. So when I subbed in, I simply got a minus and then b plus c in brackets because I have to be careful with my signs there. I'm going to have a squared plus a times b plus c to be squared. Now, all I did here was I multiplied minus 1 by each of these and I got a minus b minus c. So that's all I can do here. I don't have any like terms, so I can't really simplify it. A times a is a squared. If you multiply this bracket out, you get ab plus ac. Down here now, I have to multiply b plus c by b plus c. Now, so basically I have to multiply out double brackets, and I've done it down here in my rough work. So the first thing in the first bracket by the second bracket, second thing in the first bracket by the second bracket. And when I multiplied it out, my 2 middle terms were like terms. I had a BC and a CB. Obviously they're both the same. It doesn't matter what order I write it in as BC or CB. I have 1BC plus 1BC, which gives me 2BC, and then my last term is a C squared. As I go through this course, whenever I have something like b plus c to be squared, I'm going to most of the time go straight to this line. What you need to be doing in each question that we go through is you need to be writing out your double brackets and multiplying it out. A lot of students make silly mistakes trying to do that in their heads. Every time you're multiplying a bracket by itself or you're multiplying out double brackets, you should do it like this just to be safe. When I multiplied it out anyway, I got b squared plus 2bc plus c squared. And then I looked here to see if there are any like terms, but there are no like terms there. Every term has different variables in it, so I can't actually simplify it. All I can do now is, those are my 2 factors and I can leave it like that. Part 5 here is the way that I think the difference 2 cubes or the sum of 2 cubes is most likely to come up. Cast your mind back to the first video we did on algebra. In one of those questions we were trying to factorise, and you had to factorise out what was common and then factorise the difference 2 squares. This is the leave insert equivalent of that kind of factorising that could have come up at junior cert. In this question we have 128x plus 250x to the power of 4. We first need to factorise out what's common or something common and then get the sum of 2 cubes. We'll have learned off that x cubed plus y cubed is equal to this. You would have to look at this and realise that if you divide 128 by 2, you'd get 64. And 64 is the same as 4 cubed. If you divide 250 by 2, you get 125, which is the same as 5 cubed. you got to obviously play around with your x's as well. I don't want to have x to the power of 1 or an x to the power of 4. If I'm dealing with if I'm trying to get the sum of two cubes, I either don't want any x's at all or I want an x cubed. So what you need to be able to look at the first line. It'll probably take a minute or two to figure it out, but you have to realize that if you factorize out 2x, you'll be able to get the sum of two cubes for these two. 2x into 128x is 64. 2x into this is 125x cubed. Luckily for us, 64 can be rewritten as 4 cubed, and this can be rewritten as 5x all to be cubed. So now we have a 2x, and then the two terms in here can be factorised using this formula that we've learned off. I know x cubed plus y cubed will give me this, which tells me that 4 cubed plus 4 cubed plus 5x cubed would end up as 4 plus 5x times 16 minus 20x plus 25x squared. And throughout the whole question, you just have your 2x outside it. So you have 2x times this, and that's it factorised fully.